galaxies.
우리 갤럭시에만.
That's a count. And then the 100 billion other galaxies should be the same. So it's many, many, many black holes.
That's now proved theory.
It is accepted.
Accepted.
I would say.
Accepted.
I mean, it's not proved, but it's accepted as these numbers, yes.
이거는 증명이 됐다고 말할 수는 없어도 인정될 수 있는 설이다. But why do you study black hole? 블랙홀은 왜 연구하는 거야? 그런 거 연구는 뭐야? Why?
Well, several reasons. One is that they capture the imagination. They are very interesting objects. And the other reason really is that it's really what I explained, is that Schwarzschild described the possibility of black holes after Mitchell and Laplace. Yes, they can exist, but can you prove that there is one here? It's a different story. There is a theory on paper. Can you prove that they exist? And this is what a lot of astronomers have been trying to do, to find black holes, to show that they exist in nature. And now, most astronomers believe, beyond reasonable doubt, that they exist. Because we don't know of any other explanations, for instance, for this star that is being peeled off and this X-ray emission. It's very hard to explain these systems. Or also, I didn't mention, but at the center of our galaxy, we think there is a big, big black hole of 3 million times the mass of the sun. That's 3 times 10 to the 6 times the mass of the sun. There is a big black hole there. And the reason we know about this one is because we look at the stars very close to the center, and they go on very, very fast orbits, several of them. And so from the laws of gravity, even Newtonian gravity, we can look at the size of their orbit and the speed of their orbit, and we know that they are orbiting what is essentially a very compact mass of 3 million solar masses. And the only explanation of physics that is acceptable is that there is a huge black hole there.
We can see it?
We cannot see the black hole itself.
No. Of course,
the stars,
orbit?
Yeah.
Oh.
So there are pictures that may be shown, in fact, where you can see the orbit of stars like this, and then another one like this. So you see stars move. It's very rare because, in general, in astronomy, we don't see star moves. But the speeds, because of this black hole, the speeds of these stars are so fast that from year to year, we see the stars move. It's almost the only case we know of. It's very rare to see them move. It's very hard. And so they all go around this point here, or almost point, and we think we can measure the mass, and it has to be a black hole because anything else would be bigger. Any gas, ball of gas or whatever that we can think of in physics would be bigger than the orbits. So we think by elimination it has to be a black hole.
Okay. 그러니까 우리 거대 은하수의 한 가운데에 지금 이론적으로 상정하기는 이 태양의 3밀리언인가 이렇게 되면 300만 배 태양의 300만 배 사이즈 되는 것이 그 압축된 그 블랙홀이 요 가운데 있다고 지금 보는 거예요. 전체 가운데. 그럼 어떻게 근데 그건 현실적으로 관측이 가능하다는 거예요. 왜냐하면 여기에 아주 작은 규모의 그러니까 엄청난 별들이 거기서 이게 중력으로 설명되기 어려운 그런 빠른 속도로 거기서 돌고 있다는 거야. 그 주변을 이렇게 샥 이렇게 하면서 계속 돌고 있다는 거야. 근데 그것이 전부가 근데 요 작은 이벤트의 그 주변을 막 지금 돌고 있는 것이 현실적으로 관찰이 되기 때문에 요 센터에 지금 여기에 어마어마한 블랙홀이 있다. 이렇게 지금 보고 있다는 거예요.
So to conclude, we believe there is a supermassive black hole like this one in every one of the 100 billion galaxies as well, or almost every single one of these. So there is a lot of these stellar mass black holes, but there is also a lot of these supermassive black holes. So the conclusion is that astronomers believe now black holes are everywhere in the universe. They're just difficult to find, but they are everywhere. And they are not dangerous for us. That's the last point I want to make, because we are far from them. They are far away from the sun and the planets, our solar system, that we don't feel directly the strong effect of the gravity. But still, they are out there everywhere in our galaxy and other galaxies in the
그러니까 그
universe.
모든 이런 은하계가 지금 100 billion galaxies가 있다고 그랬는데 그 모든 이 갤럭시의 가운데, 정가운데에 지금 이런 스타일의 그 블랙홀이 있다고 지금 되게 상정을 한다는 거야. 그러니까 아마 그 가운데, 그 갤럭시 가운데는 꼭 그런 지금 블랙홀이 있나 봐. 그래서 그런 아마 뭐가 영향이 있을지도 몰라. 그 분포가. 그러나 하여튼, 그건 잘 모른다는 거고, 하여튼 모든 그런 갤럭시에 이렇게 있다. 그리고 아까 얘기했듯이 내가 왜 이런 걸 했냐 그러니까는 그 슈바르츠실트라는 사람이 이론적으로 그 또 아인슈타인 상대성을 그러니까 일반 상대성을 응용해서 자기가 이 이론을 이렇게 만들었는데 그 이론이 실제로 현실적으로 그 현실적인 은하계의 모습에서 관찰될 수 있고 그게 증명이 되니까 그게 재밌다 이거지. 그래서 연구를 한다 이거야. 그 불란서에서 공부를 열심히 한 사람이니까 in France the student like this young student, high school kids, to enter college they have to take baccalaureate exams. They have a kind of essay style questions.
Right. So to enter the university, you have to pass this national exam in many different subjects. And then if you do well enough, you're given the baccalaureate, is the name of this exam. And then you can go to university, to college. And the first exam, always, every year, before everything else, is philosophy. And it's one of the most important and one of the difficult ones, too. Because usually they give you 3 questions, and they are very abstract philosophy.